Welcome back to The Explainer. Today, we are taking a really deep, hyper-focused dive into the absolute heart of data manipulation, selecting and filtering data. More specifically, we're going to master precision indexing and Boolean filtering in Pandas. So consider this the pro explanation you need to pull exactly the data you want, exactly when you want it. Let's get into it. Look, it's a known fact in the data world, and I just want to validate this right out of the gate. This is one of the trickiest parts of Pandas for newcomers. Seriously, if you've ever pulled your hair out because you couldn't figure out why your data query was throwing a giant error instead of just giving you a data frame, you are completely normal. It's universally acknowledged as a massive hurdle. And that's exactly why we're taking this full explainer to intentionally slow things down, unpack the actual mechanics, and get it completely right today.
So here's our roadmap for today. First, the Pandas indexing challenge. Second, basic column selection. Third, loc versus iloc. And fourth, mastering Boolean filtering.
Okay, starting with part 1, the Pandas indexing challenge. The core problem. The primary conflict every single developer faces when navigating Pandas is getting exactly the data you need without triggering a massive wall of confusing indexing errors. I mean, it sounds so simple, right? You just think, I just want this specific column, or maybe these specific rows. But because Pandas is incredibly powerful, it demands very precise instructions. Understanding the exact mechanics behind how Pandas indexes and filters data is literally the key to avoiding those red error blocks that trip up so many intermediate coders. Today, we're replacing all that guesswork with pure precision.
Moving on to part 2, basic column selection, the foundation.
We're going to start with bracket notation. This is your quick and easy way to grab basic columns. When you just need to pull a single column, or maybe a quick list of columns out of your dataset, standard bracket notation is the absolute easiest starting point. You literally just use the square brackets right after your data frame name. It's a quick win, it builds your confidence, and honestly, you're going to use this every single day.
All right, part 3, loc versus iloc, labels versus positions.
So the crucial point here is this fundamental rule of thumb, .loc. You use .loc when you are referring to labels. Really anchor that word in your mind, labels. This means you are looking for exactly what the index actually says in plain English, or plain data as it were. If you want a column literally named sales, or if your index is a meaningful date like January 1st, 2024, you are looking for a label, and therefore you use .loc.
Now, in direct contrast to that, we have .iloc. The I stands for integer location. You use .iloc when you are referring strictly to physical positions in the dataset. Imagine just pointing at your screen and saying, hey, give me the first 5 rows, completely regardless of what the label of that index actually says. It really doesn't matter if the row is labeled apples or row Z. If it's physically sitting in the number 1, 2, or 3 spot, .iloc is going to find it based purely on that numerical position. And this brings us to a subtle but incredibly important difference when you start slicing your data. With .loc slicing, it is inclusive of the end label. So if you ask for A through C, you get A, B, and C. But with .iloc slicing, it is exclusive of the end position. It behaves exactly like normal Python list slicing. If you ask for positions 0 through 3, it gives you 0, 1, and 2, but totally excludes the 3. Keeping this inclusive versus exclusive rule straight in your head, that is going to save you hours of debugging.
Which brings us to part 4, mastering Boolean filtering. This right here is the boss battle.
There is a trap here that catches almost everyone, and we call it the Boolean trap. A super common mistake is trying to use standard Python and or keywords directly inside a Pandas Boolean filter. It feels totally natural because, well, that's how we write regular Python code. But doing this in Pandas, it will instantly crash your query.
So let's map out exactly what Pandas demands from you instead. You basically have to throw out your standard Python words like and, or, and not. Instead, Pandas requires specific bitwise operators. You need the ampersand symbol for and, the vertical pipe for or, and the tilde for not. Pandas absolutely requires these specific bitwise operators so it can evaluate conditions across entire columns of data simultaneously. To make this completely bulletproof, here is the exact mandatory syntax sequence for combining multiple conditions cleanly. Step 1. Write out your individual condition. Step 2. Wrap that specific condition entirely in parentheses. Step 3. Combine it with your next wrapped condition using the ampersand, pipe, or tilde. I promise you, if you follow this simple 1, 2, 3 sequence, your filters are going to work perfectly every single time. And I literally cannot stress this next point enough.
Parentheses are absolutely mandatory because of operator precedence. Those bitwise operators we just talked about actually have a higher precedence than comparison operators like equals or greater than. So if you forget to wrap your conditions in parentheses, Python evaluates things in the completely wrong order and you get a very confusing error. So here is your pro tip. If your Boolean filter fails, checking for missing parentheses is the very first thing you need to do.
Wow, look at what we've accomplished today. You now own the core indexing foundation for Pandas, from standard column brackets to .loc for labels, .iloc for positions, all the way to navigating that tricky Boolean mask trap. Knowing these techniques forms the absolute bedrock for everything else you are going to do in data analysis.
But of course, the data journey doesn't just stop here. Which brings me to one final question for you. Are you ready to handle missing data? Because in part 5 of this series, we are going to tackle a topic that every single real-world dataset will eventually force you to deal with. Real data is rarely perfectly clean, and knowing how to handle those inevitable gaps, that is exactly what separates the novices from the pros. Thanks for joining me for this explainer. Keep practicing your loc and iloc, and I will see you in the next one.